So yes, agricultural environment actually pose two major challenges for mapping with a mobile robot. First of all, they are usually very large, they can span for multiple acres, so mapping starts to be a very slow and tedious task to achieve. And secondly, they offer continuous visual changes through the here, as you can see from this image. So if you want to deploy a robot long term for multiple months, we may actually be required to do the mapping again before the robot can be fully autonomous. So the question that we try to answer with this work is actually, can we reduce the number of maps that are required for deploying a robot on a long-term scenario? Okay, so we actually started investigating the answer by collecting a long-term data set, deploying a robot in a Greek vineyard between March and October 2022 at variable frequency, so to accommodate the visual changes that may be present in the crops. And for each session, the robot is deployed on a topological map, running autonomously for 25 minutes, collecting a large number of sensors from a point cloud coming from the Velodyne and like a couple of RGBD images. And in this video, which runs at 4 times faster than the real world, you already get a glimpse of how the environment looks like in July. Like looking, for example, at the point cloud and the RGBD images coming from the frontal and lateral camera. So how did we move forward from it? We actually section our dataset, which is hosted on a MongoDB instance on the cloud, and it will be publicly released if you want to play with it. We extracted 4 sessions, and for each session, we actually tested localization performances, creating an experiment like matrix, grid matrix, cross matrix experiment in which we create a map for every single session, and then we run a localization for all the possible combination of map and data recording. This is to understand, like, if we have a map in March, can we use it in July? And as you can see from the table, and as we can expect it, the best performances are on the main diagonal, meaning that deploying the robot in the same map when the map is actually built leads to better performance. And we notice a gradual degradation in the performances the farther mapping and deployment occurs in time. So we actually wonder, these maps are similar one with another because they belong to the same environment. So can we exploit similarities between these maps? And we did that, like introducing the concept of like instability, which is very different from static and dynamic in a urban environment. Like instability in agricultural domain can be seen as like those features that change and evolve over time, and usually they are like associated with like the foliage that, or like a fruit that borns, grows, and then it is harvested and it disappears from the map. So we actually did our work. We introduced self-supervised regression network. They try to learn the stability and the instability of each point in the map. And for example, the output of this network is a stability score that will tell you how much a point is stable in time. And for example, we can have like points associated to the vine trunks and to the poles in the vineyard as like stable because they are there forever, for 12 months, for like 100 years, and like the points associated with the leaves actually they disappear once in a while, so basically they are unstable. So then we use the output of the network to prune our map, and we rerun the localization on the filter map. And the result actually confirms that we can not only improve the successful performance we already before, using, let's say, the complete map, but we can also solve those situations where an existing failure was identified. So this experiment, this work actually showed that we can actually reuse existing map, even though they are not exactly the same, or similar to the current appearance of the environment when we deploy the robot. And with this, like, I thank you for listening to me, and I know that you are hungry. But yeah, I can answer a few questions now or like during the lunch break.